Welcome everybody. I'll just share my screen if that's coming through.
Yep. All good.
So thanks for the introduction. Yeah, as Matt said, the idea of today's webinar is all about make the connection. So I'm going to begin with the importance of connectors and how to achieve efficiencies both in the design and at the install stage. So yeah, a few things to go through today. So we'll look at design stage, we'll look at how we understand the structure and the connectors. We'll look at some of the current practices, both good and bad. We'll go through, some alternatives to what's been, the standard for quite a number of years. And we'll look at, the build, simplify the install, creating efficiencies in the connectors, and finally, understanding the connector timber link. So when we have a look at any structure, regardless of how many levels it is, we'll concentrate on residential stuff today. We have various loads acting in both directions. These connections effectively start with the roof material and then work all the way through each individual element until they transfer the load, until the loads effectively terminate down at the ground level. We have the dead and live loads that increase from the top down as more and more dead live loads get added to it, and the reverse for uplift. So uplift at ground floor being relatively low due to the weight of the structure holding it down, up to your higher uplifts basically incorporated into your roof structure. When we look at the connections between all the timber members, it creates critical links and a complex path. When looking at tie downs, the uplift's trying to pull the structure apart, and it's important to ensure that every connection works effectively as part of a link in a chain. If a link in the chain breaks to the structure, then a major failure may occur. Under gravity, timber's good in compression, but a similar analogy can be used where gravity needs to pass through, say, a hanger. The load transfer, if that hanger connection is the broken link, then you can actually have the reverse failure where you have a failure in the dead load. A lot of these connections have been done the same way since I entered the industry 30 years ago, but new and alternatives, are constantly emerging. So if we start with roof to support connections, still majority of cases, we're still using triple grips and cyclone ties, hand nailed originally, especially the smaller connectors are still hand nailed. So they're actually a time consuming product to install. We've seen the evolution, pneumatic guns. People started using the pneumatic guns for installing all the products, whether they were the small connectors like triple grips, strap bracings, things like that. And over a period of time, the QBC and inspectors and certifiers and the general industry noticed that there's quite a poor practices being observed. So about 2015, the QBC brought in a ruling and basically said clout guns and things like that aren't suitable for small connectors like triple grips, and effectively limited them all to strap products. So I've had a look at a few more examples of some poor installation. You can clearly see that trying to use a clout gun on small connectors, meeting the requirements of the connector, meeting edge distances, you can't shoot through the same holes and things like that, because otherwise a clout gun cannot find the hole correctly. And we look at the cyclone tie and it looks like it's actually not too bad, but it's probably been applied with a bit of extra overpressure through the air guns. We sort of evolved more recently. There's been probably the last 5 or 6 years, there's been quite a few positive placement tools circulating in the market. There's some newer ones that have been coming out in recent times, which actually do provide a fairly good locator for the nail that you can actually punch through the existing holes. So check with the supplier of your product. They would have done some testing as far as how the positive placement nails work with their systems. So these are a new option for a traditional product, which actually allows you to use the pre-punched holes as your nailing pattern rather than trying to create pneumatic nails through the steel and observing all of the minimum edge distances and getting a similar nail pattern to what the punched holes might have been. So now we move into some slightly newer products. We're looking at things like, chippies are still running airlines all over the sites, having gas guns. We hear feedback saying, they don't want to keep on running airlines. Do they even want to buy the new positive placement tools? So we all know they carry their impact drive around. So all the new hold downs are basically moving towards a screw install. Can be done from inside the structure, speed up the installation, and in some cases may actually help reduce your workplace health and safety requirements for being outside of the wall frame, especially on your multi-level structures to nail off the members. Whether this be a direct screw into the truss as per that first image on the left, or screw connectors, these are probably going to be the next generation of hold downs, offering quick install and suitable in locations where concealed connections are required. For example, your exposed rafters or veranda situations where the beams are exposed and you actually don't want to see your hold down connection fixed to your timber beams. For those that might be up in North Queensland or regularly deal with concrete block structures, various options aside from the traditional cleat options. So block flast or strap options, which will still hook into your bond beam and your Rio in the bond beam, and then can be installed with either clouts or pneumatic nailing, or move into actually chem set screw fit brackets, remove the errors for the cleats, and reduce the fixing with the truss in regards to having to drill out your M12 and M16 bolts through the cleat. So for your roof to support considerations, we look at all the new options in market and they offer faster installs, reduce some of your workplace health and safety requirements, concealed and reduce errors of installation, and help with incorrect use. Those photos there of a recent inspection that I did, trusses on top of a steel beam, 45mm pole plate. They've nicely nailed 4 hand nails into the cyclone tie, but they actually pre-pilot hold the strap, but still don't meet minimum edge distances required for the nailing. So basically we converted those into a screw fit connections, and it's a much nicer fit. We know the tie down's adequate. We've met all the requirements for the tie down, and we know that the result is engineeringly correct. Similar with the cyclone tie at the top right there, it's an unpunched strap, nailing in a nice pattern through it, so we know it's going to work. The only query I would have is whether the air pressure was probably slightly high with the way that it's impacted onto the strap itself. So once we've got the roof to support connections resolved, we need to actually consider the supports themselves. Wall frames I'll only touch on really briefly because we'll hear more about them shortly from Cece, but there are alternatives available in relation to the tie-down rods, again with screw options, and used in conjunction with the new strapping that's been adopted by 1684 in the latest revision. Poster beams, traditionally bolting is still probably considered the most practical option, whether it be a timber or steel beam. However, an understanding of the applied uplift is important. This is an example of an open N4 job, which I was recently involved in, whereby the total uplift by the trusses on each beam on either side of the veranda actually exceeded 270 kilonewtons. So all in general, the trusses were tied down to the beam adequately, except for the girders, which is why we were involved to review it. The connection of the beams actually may have been our broken link in this instance. 3 posts, 6 bolts to hold down the 270 kilonewtons. So some further investigation was worked on there with the project engineers to come up with a better solution for that connection to ensure that that link wasn't broken and we weren't going to end up with a failure of some description for the beam to post connection. Floor systems, pretty much the standard method these days, whether it's timber or steel beams, is joist hangers, but this involves putting pole plates inside the steel channels or onto the face, fixing with joist hangers. Time consuming by the time you install the pole plates, bolt them through, nailing off the joist hangers and things like that. So it is a slow process. And there are things that can go wrong. So here's a few instances where some of the common issues that we've seen. The pole plate has been fixed at the wrong height, so then the joist hangers are hanging below the pole plate, insufficient nailing. Therefore, we're going to end up with a reduced capacity. So depending on the load width, it actually may not result in that joist hanger being suitable for that product. And similar with the details on the right-hand side, we've got a vertical block with the nailing pattern required for the joist hangers. It means that the nail spacing along the grain is now inadequate. And in the far right-hand image, you can actually see that the bottom of the block is actually starting to split, which again means we're starting to lose a reduced capacity of the hanger based on the timber starting to fail. So with the issues with joist hangers, what other options do we get? So we can actually start looking at hanger-free options. Simply by planning your beam heights along with the coordination with your fabricator, it's quite easy to achieve a majority hanger-free floor system. I won't say you'll get rid of them all, by simply using top chord supports or keyed into steel beams. So there's a few standard type of details that can be used in conjunction with either timber beams and steel work, which don't require any hangers, and effectively you can just skew nail down into the various members, and in the case of steel, top chord supported, use power actuated nails for the fixing details. Here's a few instances of those details physically used on site. Quite easy to key into steel, quick and easy to install, slide them into place, skew nail them in, and move on to the next step. Similarly with top chord support, can be multiple options. So the first image there, you can see there's been a pole plate installed on top of the beam. Therefore, you can just skew nail straight down into that timber plate. The middle image doesn't have the timber plate. The steel height goes hard up underneath the top chord, so power actuated nails or a screw down through the top chord into the steel. And similarly with timber beams, you can actually have top chord support on timber beams and not have a need for putting joist hangers onto the timber beam. So once you go hanger free, it starts opening up new options and further off-site prefabrication by using floor cassettes. So once you can have basically what you can do, have the fabricator produce the floor cassettes for you, bring them in, crane them into place, and you basically end up just fixing them in with nominal fixings, utilizing the direct supports, hanger-free options onto beams, straight onto your top plates, and it creates a much faster and more efficient build. Even by simply going hanger-free, we've had reports that there's considerable savings in time in the installation process compared to when you look at the time of actually fixing into the pole plates and the joist hangers into the system. So once you have all of your adequate connections, the next important step to understand is the importance of the joint group of the timber you're actually working with. With sawn timber, it's fairly easy. AS 1720 provides tables for the joint groups of all the various timber species, and these can be used in direct calculations with the fixing strengths. Even with MGP pine, widely used, however, there may be actually differences with the joint group depending on whether the timber is locally produced here in Australia or if it's an imported product. So it's important not to assume that all MGP stress grades, regardless of the species, will have the same joint group. So it's always important to confirm with your supplier what the joint group of the material and the timber that you're using is. Similarly with EWPs, but probably even the next level of importance. So all manufacturers have their own, let's call it a recipe for the production of their product. they use that based on what design properties they're trying to achieve. Each lamination actually has the potential where it could actually be a different species throughout the LVL, and that may actually have a bearing on the final joint group that product has. You could also end up with the face and the edge of an LVL actually having a different capacity or a different joint group. So an understanding of each of the individual EWP producers is highly important to understand when you're designing your connections, to ensure that the face and edge that you're actually fixing to does actually have the joint group that you're working towards. As nail plate suppliers, we also do a fair bit of independent testing with regards to our plate grip across both sawn and, more importantly, EWPs. The tooth group with the EWPs is very specific to each individual LVL product. So every product that is available on the market and used in software, we've tested for the grip, and they've all got their own specific properties. So regardless of whether you're looking at screws, nails, bolts, or even for us, the nail plate connections, it's important that the EWP is that you always refer to the manufacturer's literature and never substitute one product for another. It's always important, yeah, if you need to substitute or need to change it because something's not available, then yeah, redesign it for the properties of the product you're actually going to use. So our key takeaways from today, so to optimize design, you can optimize your connector usage. So the more time you can spend right back to the design stage, you may be able to get a better solution for the different types of connectors you're trying to use through your structure. Are traditional still the best option for this situation? Maybe they are, and cyclone ties are still going to be around for a lot longer, but there's just be aware of the new options and what benefits that they may have for your upcoming projects. The new products may be more efficient and save time. So, save time, save material, save labor, and may even give you some WH&S benefits. And always remember to understand your joint group to maximize your connector performance. Thanks, Matt. Any questions?
Awesome. There was one question. Oh, there's no one popping in. One question that I half answered for you, but from Charles, is there a mandatory requirement to ensure nail spacing and edge distance are maintained in triple grips?
I would ensure that your edge spacing for the triple grip to the edge of the timber is as per the guidelines, but the actual nail fixings within the product themselves have been designed and tested for each of the components. So we do our own testing for the uplift capacities of the triple grip and the design of the nail spacings within it. But yeah, it would be important to whatever you're nailing into to ensure that you are meeting edge distances. So double top plate, just ensure that there's no nail trying to go through between the two laminations and things like that, which we do see occasionally.
I got another question from Matthew Scott. How far can a truss boot hang below the supporting member?
I guess I'll speak from ours at the moment. We've done some testing and got some data sheets there for about 45 mil below the timber at the moment without losing any capacity. But yeah, it depends on the situation, depends on how many fixings that you lose and what you actually get to load widths and things like that. So it's really a case-by-case basis as to what we can achieve. But we've done some generic testing to get to about 45 mil, which is a fairly common one that we've come across.